Good afternoon. Today we're going to be going over our 3.1 notes, which covers slope. This is something that you have absolutely seen before, at least most of the notes you've seen before. So today should be a breeze. I am going to move kind of quickly through this because our notes are quite lengthy today. But again, with you having already have done this once before, hopefully you just need a quick refresher and you will be good to go. The learning target for today is I can calculate the slope of a line and explain its meaning in the context of mathematical and real-world problems. We have 3 vocabulary words today. The first vocab word is slope, and slope is the change in your y values over the change in your x values. So this is going to be the change in y over the change in x. If you ever see the phrase rate of change, that's just another phrase for slope, so don't panic when you see it. And then slope formula is a tiny baby formula that you learned in middle school where if you were given 2 coordinates or 2 points and they asked you to find the slope between the 2 of them, you would use the formula y2 minus y1 over x2 minus x1. So those are 3 things that we need to know for slope. Change in y over change in x, rate of change, and then your slope formula. We're going to start by finding slope from a graph, and I've actually kind of given you a step-by-step instruction here, like what to do first, and then just other important pieces of information. So to find slope from a graph, we're actually going to do our rise, which is our change in y values, over run, which is our change in our x values. Oh, I just said that. Rise is the change in y values, and then run is the change in x values. So I won't need to put that there. It's just extra info. And then as a reminder, the directions up and right are positive directions, whereas down and the left are negative directions. That's going to be really important when we are looking for slope from a graph specifically. All right. The first part of our notes say, find the slope from each graph. Remember to simplify all fractions. So when we find our slope, you might have a large number over another large number just because of how you decided to find your slope. If that happens, you need to try to simplify it as small as possible, okay? So what we're going to do first is find the rise of our graph, and then we're going to find the run of our graph, and then we're going to put it together to get us our slope. So it is always up to you which points you choose. I have a habit of always picking the lowest point and then moving upwards towards the next point. So I'm going to start at that bottom point that I have circled, and I'm going to move to my middle point that I have there. So the first thing that we do is we start with our rise. So that is how much up or down we are going. So for me to get from this coordinate to this coordinate, I am going up 1. Because I traveled in the up direction, that's a positive direction, so I'm going to label that as a positive 1. And now I have to do my run, which is going to be to the right, and I'm going to go to the right 2 places because I traveled to the right. That's also a positive direction. So right now I've got a rise of a positive 1 and a run of a positive 2. That is going to make my slope a positive 1/2 because it's rise over run. I'm going to move over here and do it again. I'm going to start at this bottom coordinate, and I'm going to move to this middle coordinate here. Okay, my rise is always going to be up or down. I'm going to be traveling up 1, 2, 3. So I've gone up 3. And now I'm going to run 1, but I went to the left, which is a negative direction. So my slope is a positive 3 over a negative 1, which just simplifies down to a negative 3. We're going to look here at this horizontal graph. I'm going to do my rise first. I'm going to go from this left coordinate to this middle coordinate. And in order for me to rise to get from my blue point to my red point, I'm actually not going up any. I don't have to travel in the upwards direction or the downwards direction. I'm just hanging out there. But I am going to run. And I'm going to run 1, 2, 3, 4. So I went to the right 4 places. So the slope of my horizontal line is actually going to be, I'm going to write this over here for a second, 0 over 4. And then if we plug 0 over 4 into our calculator, scooch. If I plug in 0 over 4 in my calculator, 0 divided by 4 actually just gets me 0. So the slope of this line is 0. And that's true for all horizontal lines. Anytime that you have a horizontal line, it's going to be 0 because you don't have a rise. One way that I like to help my kids remember this is the horizontal line makes a z with the x-axis for 0 slope. Just a little way to help you remember. Now, the reason that I do that is because it's going to be very similar when we come over here and we look at our vertical line. So I need to do rise over run. I'm going to start at this bottom blue one. I'm going to move to this middle one here. I'm going to go up 1, 2, 3, 4, 5. So I've gone up 5. But I'm already there, so I actually don't have a run at all. Now, I am going to plug this in my calculator. Sorry that I keep going back and forth, but it doesn't let me change my stylus tool when I'm in my calculator. So I'm going to be doing 5 divided by 0 in my calculator, and when I hit enter, it gives me an overflow error. Whenever you do this in the school calculators, it's going to also come back as an error. The reason is you are not allowed to divide by 0. You cannot take a number and divide it by nothingness. So what happens when I get something like a 0 in the denominator of a fraction, it'll look like this. It'll be 5 over 0. 0 on bottom is bad, okay? You're actually going to get what we call an undefined slope. And I do this with the y-axis to help students remember that this is undefined. So a horizontal line makes a z for a 0 slope, and then an undefined horizontal line makes a u for an undefined slope. 0 for 0 slope, u for undefined slope. Okay, so I've given you an example of a positive slope, a negative slope, a 0 slope, and an undefined slope. Okay, let's say that instead of a graph, you are given 2 points and you are asked to find the slope between the 2 points. Well, in order for us to find the slope between 2 points, we are going to use our slope formula. Our slope formula is y2 minus y1 over x2 minus x1. So it gives us some steps here. It says the first step is to label your coordinates. You're going to label your coordinates with this information. So you're going to label one of your coordinates x1, y1, and then another one of your coordinates x2, y2. Once we do that, we're going to plug our labeled coordinates into the slope formula. We are going to simplify the numerator, simplify the denominator, and then reduce if possible. So I'm going to go over this first example with you. Our first step is to label our coordinates. So we are going to, well, let me back up for a second. When you have a coordinate, every coordinate or every point that you have is x comma y every time. So I take my first coordinate and I label it x1, y1. And then I take my second coordinate and I label it x2, y2. And then I have to plug all 4 of those numbers into this pink formula up here. So wherever y2 is, that's the first thing that I've got. I'm going to plug that in first, and then I'm going to subtract the y1 value. Before I do that, though, I do want to point something out. Your slope formula has these minus signs here. So no matter what, you must have a number minus another number, okay? All right, so let's start here. We have y2 minus y1 over x2 minus x1. So this minus sign here is from the formula up there. Okay, so those minus signs must go in your formula. But my y1 value and my x1 value are also negative. So I actually have 2 negatives right now, and that's okay. All right, so what I'm going to do is now that I've plugged everything into my slope formula, so I've done step 1 and I've done step 2, my step 3 is to simplify the numerator. So if you did this in your calculator, if you do 8 minus negative 4, that is the same thing as 8 plus 4, and 8 plus 4 is 12. Now I'm going to simplify my denominator. 4 minus a negative 2 is really 4 plus 2, which is 6. Okay. I simplified my numerator, I simplified my denominator, and then step 5 says reduce if possible. Can you do 12 divided by 6? Yes, you can. When you do 12 divided by 6, you get 2 as your slope. Let's do it again. We're going to do it with this example here. We've got our x1, y1, and our x2, y2. So the formula is y2 minus y1 over x2 minus x1. These minus signs are from the formula. I'm going to simplify my numerator. 7 minus 8 is a negative 1, and then negative 3 minus 5 is a negative 8. If you have a negative over a negative, you actually end up with a positive. So my final answer, my final slope simplified, will be a positive 1/8. Let's take a look at number 3. We've got our x1, y1, and our x2, y2. So we've got y2 minus y1 over x2 minus x1. Remember that this minus sign is from the formula. This will be, sorry if you hear my dogs barking, negative 2 plus 6 over negative 1 plus 1. Negative 2 plus 6 is 4. Negative 1 plus 1 is 0. Oh no, we have a 0 in the bottom. 0 in the bottom is bad. That means that I have an undefined slope. Lastly, we will do x1, y1, x2, y2. This will be 3 minus 3 over negative 2 minus 5. This minus sign is from my slope formula. This will get me 0 over negative 7. 0 on top is okay. 0 over anything is fine. My final answer will be 0. And that is how you find the slope between two coordinates or 2 points. So if I were to graph those coordinates like in Desmos, I'll show you. I'll do negative 2, negative 4, 4, and 8. So I'm going to go to Desmos. Let's see. Where is my Desmos? La, 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 la. Okay, not any of them there. Let's see. Desmos, 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 Desmos. Here it is. Yeah. Okay, so I have, what is that? Negative 2, negative 4, and 4, 8. So we've got negative 2, comma, negative 4, and then we have 4, comma, 8. So if you were to look at your 2 points here, what you could do, and it's going to be really hard for me to do because I don't have a pointer, I can't draw on Desmos itself, but you can actually try to count the slope between those 2 points. So you can go up 2 over 1, 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 and it is true that you will get, trying to zoom in a little bit. Come on. It's not going to do it. But you'll be able to see that if you go from the red dot to the blue dot, if you go from the red dot, if you go up 2 and then over 1 and then up 2 and then over 1 and then up 2 and then over 1, you will end up at the blue coordinate. Okay, so that's kind of a way you can check yourself. Okay, so there you go. Now, finding slope from a table, there's actually 2 different ways to do this depending on who your teacher is. I'll show you both ways, and then you can choose, or your teacher may tell you, I want you to specifically do it this way. For my kids, I don't care how you choose to do it, but you just need to make sure that whichever method you choose, you get the right answer. So whatever you like the best, you may do. It does say here to find the slope from a table, we will use the slope formula, because you can. The other way you can do it is this lovely thing called the change in y over the change in x. The slope formula, again, is y2 minus y1 over x2 minus x1, okay? Or you can do this change in y over change in x. They are essentially the same thing. So let's say that we decide to use our change in y, or I'm sorry, our y2 minus y1 over x2 minus x1. If we do that, we need to choose 2 coordinates. I typically just choose the first 2 for no reason other than that's what I want. So this will be my y1 and my y2. This will be my x1 and my x2. So the coordinates, instead of being like this, are up and down. So this coordinate is actually 5, 0, and the other coordinate is 10, 1. So you can either rewrite them if you want, or you can just label your graph or your table like this. It doesn't really matter, okay? So either way we do this, we will do y2 minus y1 over x2 minus x1. This will be 1, over 5, and your slope is 1/5. So that's how you would do it if you decided to do it using your y2 minus y1 over x2 minus x1. The other way you can do it is the change in y over the change in x. And the way that you do this is you look at your y values and you say, what am I doing to get from term to term? You are adding 1. Over here, you would say, what am I doing in my x values? You're adding 5. So the change in y is 1, and the change in x is 5. It's change in y over change in x, so that would be 1 over 5, and either way you do it, you will get 1/5. Sometimes it's easier to do y2 minus y1 over x2 minus x1, especially if your table does not go by the same number the whole time. So my suggestion is for you to do y2 minus y1 over x2 minus x1, but it doesn't really matter here, okay? All right, let's go to number 2. I'm going to pick the first 2 here. This is x1, x2, y1, y2. So we will do -4 minus -2 over 18 minus 20. Remember that this is from the formula. Okay, I'm going to go this way this time. This will be -4 plus 2 over 18 minus 20. This will be -2 over -2, which just simplifies to get you a positive 1. So that is my slope. If I had done it the other way, the change in y here is -2. The change in x here is also -2. -2 divided by -2 is still a positive 1. So it doesn't really matter which way you do it. Taking a look at number 3, you got your x1, your x2, your y1, your y2. We have 5 minus 6 over 2 minus 2. That's -1 over 0. Oh no, 0 on bottom is bad. That means that we have an undefined slope. And then lastly, we're going to look at number 4. We've got x1, x2, y1, y2. This will be -3 minus -3 over -2 minus -1. This negative sign right here is from the formula itself. This is -3 plus 3 over -2 plus 1. That's 0 over -1. 0 on top is okay. That makes my slope 0. And that is how you find slope from a table. So you've got 2 options. Pick whichever one you prefer. Just make sure that whichever way you do it the right way. All right, let's move on to application problems. This is pretty easy. This, I think you did it quite a bit in middle school. So I'm going to give you a word problem, and we're going to try to figure out which one of these parts of my word problem is my slope or my rate of change. What is the thing that has a constant change in every, piece of this problem? So number 1 says a jewelry maker charges a flat fee of $50 for a chain for a necklace. Any charms you want to add to the necklace will cost you $23 each. Find the rate of change for this problem. So we have to be careful because I think whenever you are originally taught this, your teachers tell you to look for keywords like each or every or, per or things like that. And although that is true, your rate of change / slope will come from words that have that in there. As you get into more complex mathematics, they might use every or per or each for multiple parts of your problem, and it might not actually be what your rate of change is. So when you look at this question, you say, am I paying $50 for multiple things? Well, you're paying $50 for one chain for a necklace. But if you want multiple charms on your necklace, then you will be paying per charm. So when you look at this problem, because I have a one-time fee of $50 for my necklace, that is not going to be my rate of change. My rate of change is going to be the $23 that I am paying for each charm that I want. So your rate of change here will be 23. Number 2 says, when you buy apples at the store, you are charged $1 per apple. You must purchase a bag at the time of checkout to take your apples home in. The bag will cost you an extra $4. What is the rate of change? Are you paying for multiple bags or are you paying for multiple apples? Well, you're hopefully only paying for one bag. and you're taking a bunch of apples and putting them in the bag. So because you are paying per apple, we are going to say that our rate of change is 1, and it's $1 per apple. Number 3, airline tickets are $175 per person. You and your family want to go to Hawaii for a vacation and will purchase a ticket for each family member. However, the airline will also charge your family a one-time service charge of $100. What is the rate of change for this problem? You are not paying multiple payments of $100. That's just a one-time fee. If you bought one ticket or you bought 100 tickets, you're only paying $100 once. So the rate of change for this problem is the $175 per ticket per person. Whee! All right, and then I got through this kind of fast. The last part of our notes for today is finding a missing value. This is probably the hardest thing we have, but I'm going to explain it to you to the best of my abilities. So to find a missing value, you're going to be given 2 coordinates, and you're also going to be given like what the slope is supposed to be. If you look at both of these answers down here, notice that one of the coordinates is missing something. Okay, so normally I give you 2 coordinates and I say find the slope. This time I'm giving you 2 coordinates. One of them is missing something, but I'm also giving you slope. So we're kind of having to work backwards. We're solving an equation, if you will. So the way that we do this is we are going to use our slope formula. So I am going to start by taking the 2 coordinates that I already am given and labeling them x1, y1, and x2, y2. Okay, the slope, again, I'm already given slope. So what I'm doing is I'm taking those 2 coordinates and I'm plugging them into my slope formula. So that's y2 minus y1 over x2 minus x1. Normally, I don't know what this is on this side. Normally, I find that by simplifying my fraction, okay? However, this time I actually do know what my slope is. It is -9/5. Now you have a choice. You can put your negative either with 9 or with 5, but you just need to pick one. I usually put it on with the numerator for no reason other than it's just a habit, okay? So now that I have this equation set up, what I have to do is something called cross multiplying. You did this in middle school, okay? The butterfly method, if you don't remember what that is. And what cross multiplication is if you have a ratio on one side of your equal sign and a ratio or a fraction on the other side, you can multiply across that equal sign. You're going to multiply the numerator of one fraction by the denominator of the other. So this will be -9 times 8 minus 3. Okay, we drop down our equal sign and then we multiply the other direction. So we have 5 times 6 minus y. Okay, so my fractions get split. The numerator of one goes with the denominator of the other, and then vice versa. You have to drop down the equal sign. From here now, I can just simplify. This will be -9 times 5 because 8 minus 3 is 5, and that's -45. Drop down my equal sign. I'm going to distribute over here. This will be 30 minus 5y. This is 30 minus 5y. Okay, now I just have a good old-fashioned equation. -45 equals 30 minus 5y. From here, I'm supposed to get y by itself. I'm going to start by subtracting 30, and I get -75 equals -5y. Divide both sides by -5, and I get that y is equal to 75 divided by 5 gets me 15. So that right there is the missing value that I need in order for those 2 coordinates, when I plug them into the slope formula, to get me my -9/5. So let's do it again. Okay, so I've got my x1 and my y1, my x2 and my y2, and then I'm given my slope. So this will be -8 minus 1 over x minus 1, and then this will equal 3. Now, anytime you have a whole number, you can make it into a fraction by putting it over 1. What did I do? What color did I do? I did red and blue? Blue. Okay, so I'm going to start by taking the numerator of one fraction and multiplying it by the denominator of the other. We then bring down our equal sign. Then we multiply the numerator of our other fraction by the denominator of our other fraction, like this. The left-hand side, I will distribute 3x minus 3 equals, and then on the right-hand side, I will, well, I don't need to distribute. I can actually just take care of this. That's 1 times -9. So that's going to be 3x minus 3 equals negative 9. I will add 3 to both sides, and I get 3x equals negative 6. I hear you. And then I get x equals negative 2. So again, that is what I should get for this x value. So when I plug those two coordinates into slope form, or plug those into the slope formula, I should get a slope of 3. As always, if you have any questions, you need to go see your teacher during their normally scheduled tutorial times.